Good afternoon, everybody. Welcome back. I'm Andy Cameron-Smith, Editorial Director at Unlock Net Zero, and I'm Chair of this forum for this afternoon. So welcome back for this session, which is now going to be looking into the circular economy and looking at the links between reuse, circularity and embodied carbon. And the session will be asking how emissions can be reduced by prioritising circular economy principles in construction. We've got an expert panel of speakers to delve into this topic this afternoon. So we're joined this afternoon by Joe Giddings from Built by Nature, Penny Gowler from Elliott Wood, Ian Riley from the World Cement Association, and Elaine Toogood from the Concrete Centre. Now, if you've been in these sessions already, you'll know you can ask questions via the Slido app. If you are in there, you need to use the code #IZ24 and then select the room, which is Built Environment Forum. Otherwise, your question goes off into the ether and we won't have it. But what will happen, that will come through on the iPad, and Anna Lisa here, who is going to moderate, will be able to put those questions for you. So your moderator for this session is Anna Lisa McSweeney from White Arkitekter. So I'm now going to hand over to Anna, and the session is yours.
So thank you very much. I hope everyone can hear me okay. It's a bit weird this bit. Okay, so I was going to introduce everyone, but you've already been introduced, and there's very impressive expert speakers, and there's a much longer list on all of their bios, but we had the headlines. So we're going to be discussing what are the links between reuse, circularity and embodied carbon. And some of the things we're going to talk about around holistic sustainability, looking beyond just carbon, material flows, and what are those connections between circularity and lowering carbon. So I've asked each of the speakers to give a 3-minute presentation to see what is their position. They're all material experts from different material fields. What is your perspective from your material specialism on the link between reuse and circularity and low carbon? And maybe we can start with Elaine.
Right, so did he get me now? I need a mic, don't I? Rookie error. Okay, excellent. So, what are the links? Well, they obviously are connected, and actually, if you can think of a solution that could help with all of those, it's just stop building, isn't it? Use less stuff. But, not realistically a solution, actually, practically, for many things, not the least because obviously we're going to need to invest in infrastructure and retrofit if we're actually going to achieve decarbonisation. So let's take it, so we're looking at concrete itself. There are also links, lots of ways in which concrete can be decarbonised, and lots of things at the manufacturing and construction, but also the things that we can do within the use. And similarly, circular economy. And ticking the box for both would be dematerialisation, so using leaner, efficient structures, for example. Another one is thinking about the long-term embodied carbon, so the whole life embodied carbon. Concrete, if it's reused and its longevity value, is a potential for a low carbon resource in the future, so reducing that carbon over a long time. But actually, what I'd say is that circular economy is much, much more complex than carbon. We're all sort of grappling around with how to measure and report on embodied carbon at a building level. Circular economy is behind that and is so much more complex. And I think what's really important is that we recognise that it is systemic. We need to be thinking about it at a system. It's not about materials circling into themselves necessarily. And what's important with that, I think, is that there isn't a one-size-fits-all approach. I think that's also a really important thing. We've got different materials here. They all came into being in different ways. Their end of life will happen at different times and in different ways. So we shouldn't be applying the same metric of what good looks like for each one of those materials, I would argue. An example of that is design for disassembly and reuse. Really important for all the parts of the buildings that are likely to have a lot of churn or need to be used, but is that the right solution for a concrete structure? It won't always be. Sometimes it might be. But actually something like infrastructure, where you want that asset to be in use and be low maintenance and be operational with minimal disturbance for decades, hundreds of years, actually is it the right solution for designing that for disassembly? So we need to apply the right solutions for the right things. And I think my final point really with regards to that, I've got loads to say, Susan, I've got to shut up with regards to this, is that we need to be thinking about the end-of-life solution much more than we do up front. Concrete, there's lots of things that we could say. There's a lot of work going into thinking about and looking at greater use of concrete construction waste, how that could be used to reduce carbon by feeding that back into the supply chain. And I think that circular economy is good to know, if you don't know, that the UK concrete industry have been measuring resource efficiency and reducing waste for 15 years now as part of its UK construction industry. But of course, the whole measurement of these impacts that relate to circular economy have moved on. And so there's a refreshed strategy that circular economy is one of 4 key pillars alongside carbon, as you'd expect, that the industry is looking at in terms of its focus and how it can support concrete in its use within a more circular economy. So there we go.
Thank you.
Longer than 3
No, that was a bang on 3 minutes as well, so thank you very much. Hand the mic over to Joe.
Hello. Ooh, it's like a silent disco, but I can hear myself. It's very strange. Okay, so I'm Joe Giddings. I'm from Built by Nature. Built by Nature is an organisation dedicated to increasing the use of timber and bio-based materials. So it's specifically about circularity of those materials that I'm going to talk today. So bio-based materials have a unique attribute when it comes to circularity that's very important to consider, and that's the fact that they are almost literally made out of carbon. And this is a unique carbon cycle that needs to be considered. We find it useful to think of timber and bio-based materials in terms of 3 S's. Substitute, which is easy, which is basically just using lower carbon materials in place of higher carbon ones. Sometimes bio-based materials are the lower carbon option, but not always. The second S and the third S are more important in terms of circularity. So that's sequester and store. So we all know about sequestration. That's the function of the plant. We all learned about photosynthesis in school, and basically plants, as you know, suck carbon dioxide out of the air and they lock that into the structure of the material. So bio-based materials, such as timber, are about 50% carbon. But the third S is the most important then to consider when you're thinking about circularity, and that's storage. And that's where bio-based products come in and where circularity is particularly important. So if you use that timber in the built environment for a very long time, then it can be considered, that carbon can be considered stored. And, you know, we're talking potentially 100 years if it's a structural component in a building. So that structural component is a very good first use of that timber. But if possible, we need to then prevent that carbon from ever entering the atmosphere ever again. So it can be circulated. It can be circulated through a cascade of products. So from something like cross-laminated timber, it might be reused directly in 100 years' time. So when a building's taken apart, you could reuse that component. But then after that second use, you'd want to then turn that timber into another product. So it can be chipped up, turned into OSB board, that kind of thing. So in that sense, it's helpful to think of bio-based products as a kind of carbon pool. For as long as they are in the built environment, that carbon pool remains the size it is. And what we really need to be doing is increasing the size of that carbon pool. And that means putting more bio-based materials into the built environment, but also preventing them from coming out and keeping them in the built environment for as long as possible. And the critical thing here is thinking about when those materials leave the built environment. If they're burnt, then the carbon dioxide is released to the atmosphere. If they're put to landfill, again, over time, that is then released to the atmosphere. So yeah, that's the critical message I wanted to get over at the beginning of this, and then we might be able to talk a bit more about some examples throughout the panel.
Thank you so much, Joe. Handing over to Ian.
Elliott. So, since Elaine started with concrete, maybe I'd talk about where concrete gets most of its carbon footprint, which of course is cement. And in the cement industry for many years now, we've been looking at 3 different ways to reduce the carbon footprint. So one is energy efficiency. The second is fuel switching, so particularly moving to bio-based fuels. And then the third one is clinker factor. So this means in the cement we use less clinker and more of other things. So clinker factor isn't really what we ought to be measuring. What we ought to be measuring is the carbon footprint of the buildings that we're building from this. And that, of course, takes us back to the concrete. And there we see in London, for example, that we have standards for the carbon footprint of buildings, of new buildings that are constructed here. And when you start looking at how to reduce the carbon footprint in the building and in the concrete, you have a lot of other options. So ultimately in cement, because most of the emissions come from the limestone, we have to use carbon capture and storage. And this is a really expensive alternative. You can see there's quite a lot of projects going ahead in Europe now. They're all subsidized heavily, so thanks to Brexit, we're not subsidizing all of the European projects, but of course we're subsidizing the UK ones, which have also been announced. And these projects still only work even after the subsidies with a very high carbon price. So when you look at the alternatives of using different materials in concrete and of recycling concrete back into concrete using the fines as a cementitious material, there are a whole suite of other alternatives that allow you to reduce the carbon footprint of the concrete at the same time as improving circularity, and which are also a lot less expensive than some of the cement options. So I think in the end we'll wind up doing both, and there's plenty of room for us to do everything that we can all think of, and we still won't get to where we need to get to. So I don't think it's a question of the solutions competing against each other. It's a question of making everything better than it is today.
Thank you very much, Ian. We're going to need a padding.
Thank you, Ian. That's quite a good segue into how I was going to open this. So I'm a structural engineer by profession, so I don't have any affinity with any particular material. I just try and use whichever material suits the job that we're trying to, the project that we're working on. So when I think about circularity and what does that mean for us as structural engineers, for me, first and foremost, it means keeping materials that we have already in use for as long as possible. So that means materials inside a building, that means a particular system, like an MEP system, or it means the entire building itself. So most of my work these days is around trying to save buildings, reinvent them, repurpose them, and then if we can't actually save the entire building, then can we deconstruct those buildings and reuse the materials that come out of that building for a new project? And that has multiple advantages. One is that we are using fewer natural resources because we're having to take fewer virgin materials out of the ground. We're also creating less waste because those materials are being reused, so being taken out of one building and put into another building. And in most cases, almost all cases, it's lower embodied carbon. So it's a win-win from that point of view in terms of reuse. I'll come up with some examples later and explain some of the projects where we're doing, but we're reusing, say, structural steel at scale. So it is happening. It's happening in London, just down the road from here. But there are common issues because, as Elaine very quite rightly says, circularity is much more than just carbon. There's lots of other issues that come into circularity. In order to keep those materials in use for as long as possible, then those materials need to have a certain projected design life, or the building needs to have a certain projected design life. So one of the common questions is, do we spend more carbon now to make sure that those materials last for longer? And I think that's always a really difficult question to answer, and it's always very project specific and material specific. But there's analysis that can be done to kind of answer those questions, and that's a lot of the work that we do at the moment. My personal view, and the view that the Institution of Structural Engineers takes, the position that the Institution of Structural Engineers take, is to prioritise reducing carbon now. So designing for what we want to use it for now, because actually in the future, as the whole world decarbonises, it will be lower carbon to retrofit or change that building at a later stage. So that's my kind of rule of thumb. The final issue I wanted to raise in this opening statement aligns with what Elaine said actually earlier about it being a really complicated subject. And there isn't one metric that deals with circularity. I think there's a lot of us trying to find a metric that actually deals with it. But embodied carbon is not the metric that deals with circularity. It has lots and lots of failings in that respect. But just to give one example, talking about reusing materials, if you are the person who is reusing that second-hand material on your project, then you get the carbon benefit of the reduction in the upfront embodied carbon. However, if you are a developer who wants to knock a building down and has no interest in the materials that are inside that building, then it's a very hard argument to get them to save those materials, because there's no kind of financial benefit for them to save those materials, and there's no carbon benefit as it stands at the moment. So we have a situation where there's more demand than there is supply for reusing materials currently. Thank you.
That's great, thank you. And you kind of preempted some of the first questions that I was going to ask. And I was going to kind of start. Elaine, you mentioned about this kind of longevity if we design now with concrete and what that's going to give us in robust materials. But Penny quite rightly kind of addressed the point that can we afford to spend that carbon now with the idea of the future life of those structures. So maybe I'll just quickly amend the question and ask, what do you think? I mean, Penny's just given indication that the incentivization for reuse. What do you think currently has to happen to make reuse viable for commercial developers?
Well, you totally switched the question around. And I think that Penny's right in terms of actually the carbon focus is driving better circular economy practice, and with the reuse and in terms of a reuse of a whole structure and a whole frame, which is why I was talking about right at the beginning, is that actually that's a really simple way of being able to tick in the box both aspects. So I think there's many drivers that are making that happen, which from a planning point of view, about not demolishing, but also being able to do those future analysis. I think it's wrong to assume that longevity means high carbon. I think that's a misconception. We should all be looking, this is not about built as usual. We all need to improve things. And what we should be doing is addressing embodied carbon, but also addressing what the best solution is in terms of providing and facilitating as long a life and longest service life as possible for the elements that you're putting in there. So I don't see them as being contrary. I think they can be, but it's about how we approach it, which is why it was about a balance, and we need to be looking at what the right solution is for that specific solution. And if something is unlikely to have, we all need to be forward thinking. There's a lot of focus on we can only control what we can do now with up until construction, but actually that is short-termism. We've got to be thinking about the longer term, because that's what it's all about, isn't it? So I think that's. So if I really answered your question?
Yeah, you have done, and I'll kind of take that and move it on. I'm going to ask Joe something that will follow on from that. So how do you think, what do you think can give greater certainty for material use at end of life? You spoke about this cascading of timber through the life of the timber being kept within this pool of carbon, as you described it. So is there some tools that we can have across the industry that help ensure the reuse at end of life? And I'd also touch on when do we, this term end of life, where does that come from? And should we instead, in a previous conversation, we were talking about material health, and actually material goes through different phases, and we shouldn't talk about end of life. It's just what value is it serving at different points within the material chain.
I'll go for the end of life question first. It is a funny phrase because what does it really mean? I mean, end of life typically means the end of the product's lifespan, right? So if we're thinking about buildings, typically we look at a kind of 60-year, in the UK, we look at a 60-year lifespan of that building. So a structural material might be considered to have a 60-year lifespan, and it's assumed that after 60 years that building will be dismantled or demolished. I mean, even that assumption, I think, is slightly absurd in today's age, and looking ahead to, the challenges that are ahead of us as a society as we get closer to net zero and then beyond net zero, right? 60 years from now is towards the end of this century. I really don't think we're going to be demolishing buildings. I think we're going to be maybe carefully taking them apart. But I think the whole mindset is going to have shifted to much more of a kind of repair and maintain kind of mindset, thinking about cities as a whole. But nevertheless, we will be taking material out of buildings probably. And so, again, bringing it back to timber, what does the end of life look like for timber? At the moment, it's really just a kind of guessing game about what we're going to be doing with that timber in 60 years' time if we do take it out of the building. Around 50% of wood that comes out of buildings at the moment is burnt. Around 49% is recycled, and 1% is sent to landfill. But that's what we do now, and so it's kind of wrong to assume that we're going to be doing exactly the same thing in 60 years, I think. And really, I don't think any of us know. I like to trust that we as a society will have built better circular economy infrastructure so that all wood that comes out of buildings can actually be redirected to a new use. And we're beginning to see some of that already and some quite innovative projects, I think. So for timber, there's a researcher at UCL at the moment who is making cross-laminated timber out of old Victorian roof trusses, which I think is quite neat. So that was wood that was put into a building about 150 years ago. Now it's being taken out, de-nailed, and then actually made into a big, solid, engineered wood product. And so hopefully we'll be doing more of that, actually upcycling wood into new products. But a lot of wood is then chipped up and put into things like chipboard and OSB. And you've probably used a bit of recycled timber in your house. If you've ever bought chipboard or OSB and done anything with it in your house, then probably a percentage of that was recycled. So hopefully that content will continue to increase over time, and actually we can move towards maybe 100% recycled wood in OSB and chipboard and those kinds of products. Does that answer?
Yeah, I think it answers well. And I'm going to skip over you just now because you've made me think of something that I wanted to ask Penny. Penny, you said that what we can afford as a carbon budget today, and that we shouldn't be building anything that's carbon intensive until we have the technology in the future to do the retrofit that will be less energy intensive. Somewhat paraphrasing. I'm just wondering, in general, do you think that we need to be adding any more carbon heavy material into this carbon pool at all? And if we think about the idea of material harvesting and harvesting materials both that are either bio-based, that can replenish soils and kind of contribute positively to the planetary carbon balance, or harvesting material from our built environments as a sort of urban mining, what are your thoughts about that? Do you think that we still need to be excavating and adding more carbon heavy materials?
It's a very interesting question. As an idealistic answer, I guess I prefer that we weren't, but I live in the real world, and unfortunately there are no low carbon alternatives to some aspects of what we're building at the moment. And whilst you can argue, do we need any more buildings, I think, or infrastructure, then it's quite clear that globally we do need additional buildings and we do need additional infrastructure. And even in the UK, we still need that. We still have societal needs. So you start to push into a kind of social impact world, which is way out of my comfort zone. But just getting back to the question of have we actually got enough materials, I think there's quite a lot of research being done by University of Sheffield on this, trying to work out how much material we actually have in all of our existing buildings on the basis of, as a hypothesis, do we actually need any new materials? I think fundamentally it's really, really difficult to get to the answer because we've got such shocking records of our existing buildings and we don't actually know what's in them, generally speaking. So I think that kind of points back to something I was going to pick up from what Joe said about one of the things that we need to be getting a lot better at if we're really going to get urban mining happening at scale is actually knowing what's in our buildings and people keeping records of what's in our buildings. And then once we can have asset owners actually know, which is rarer than you might think, if they know, then you can then start to aggregate that information, which will help with that, with answering your question, I think. Thank you.
Yeah, lovely, thank you. And it's quite nice to see you picking up in some of the questions here that we're getting in from the audience. There are concerns, obviously, beyond carbon. So we have discussed something of that between us before this session, but I'll come to it when we get to the audience questions. Ian, in terms of carbon and biodiversity, embedded biodiversity. Sorry, I thought that was me. Do you think that that we're adequately accounting for the amount of energy that's going into processing our materials? You spoke quite a lot about innovations that are happening in materials, especially in concrete, what we can add to it that's different. Are we correctly and adequately accounting for the energy going into them?
So I think that there's a question of accounting, but I think there's also a question of mindset. If we look at just electricity supply in the UK, there are lots of areas of the country where development is severely constrained by the lack of electricity supply. And if you want to build a new data center in Slough, you've got to wait till 2035 before you can connect it up. And I think what this warns us of is that it's not just a question of making sure that the energy is low carbon. It's also about how the energy is delivered and about the total amount that we're using. So I think that what worries me and this actually is not quite so true today as it was before Russia invaded Ukraine and the energy prices spiked. But what really you used to see a lot of is people taking the attitude that renewable energy was essentially free and widely available, and not worrying about the overall picture of how much energy we have that can be deployed. So I think that's one of the things that we tend to worry about, should worry about rather. In the cement industry, we've always worried about Scope 1 emissions, because that's 85-90% of the total. But when you start thinking about, for example, sourcing alternative materials from a distant location, then the logistics energy starts to be very significant and the carbon associated with that. So I think there are a number of areas where we can find, and it comes back to your point, Elaine, that we have to look at the overall picture to see whether or not what we're doing really makes sense. And it's true in energy, it's true in carbon, and it's certainly true in circularity.
Okay, thank you. So I'll just go back to Elaine and Joe. I kind of put this to two of you. I used to work with Arkitekter, and he always said that timber is the new concrete. And I'm just wondering, are there learnings? We now have this very big uptake of mass timber, both in the way that it's used, this kind of silver bullet idea that we're going to kind of be able to continue building at scale with this new material. But do you think there are learnings from the concrete industry that we need to give to the timber industry as we're seeing this uptake in this material?
Wow, interesting way to look at it. Okay, well, the concrete industry is really aware of its embodied impacts, and our materials have embodied impacts, so our environmental impacts. And the industry has been committed and is committed to making improvements. So that's one thing. It's got a roadmap for decarbonisation. It's already made lots of good action. I think we're about 25% with reduction since the 30 years. But it isn't, I think what's important as well is it isn't just about carbon, and you've already mentioned that there's, it's about biodiversity and support for social value. And I think one of the things that's quite different, there's a lot of things that can be learned in terms of collaboration and informing and providing the better data, but in a way, concrete it's almost a little bit easier for concrete. It's a local material. It's pretty much all made here using locally sourced, responsibly sourced, regulated materials. Much more challenging when it's mill production or other parts of the world globally in terms of imports, getting the right, and that's one of the reasons why the data is maybe more trusted, and also, but also it's about that whole picture. I know you mentioned before something about high intensity related to quarries and extraction. Actually, aggregates really low in carbon, and actually in the UK we are very lucky. We have a very plentiful supply. And something I only learned recently is less than 0.1% of the land within the UK is allocated to mineral extraction. But you think about how much concrete is produced. Okay, and that's not just extraction, that's also landfill. So it's even less than that. So it's not a high, that extraction and use of those raw materials is not the high carbon bit. And I think that's a really important thing. And I think that's also important when we're looking at our focus for circularity, because aggregates are actually really low. And if our measure of circularity is by mass, we're putting a lot of focus on those aggregates. So is that the right focus? So it's playing back to the complexity issue. And I think, well, the only final point I want to just say about the local production is what's really important is that the industry within the UK, we're doing biodiversity net gain before it was even a term that's used. Our land within the UK is fairly low value from I think you made this point earlier when we were talking to us about agriculture and the lack of biodiversity is there. It's a real opportunity through the enhancement to enhance biodiversity, and there's hundreds of hectares that have already been provided and are planned to be improved. So I think that's an opportunity where we need to be thinking about this bigger picture. And biodiversity is what it's all about as well, isn't it, really? I mean,
yeah, definitely. And I think the point about the impact of the extraction was more to that ecological point than the carbon point. It's about land use and what we're doing with that, and to stop having this idea that we extract and we use material, but how through that material can we better and replenish and restore our natural environments. It feels a bit easier to understand how that can be done with forestry, and although it's quite difficult to quantify the value to communities or the damage both to communities and to the ecological impact with timber, we do know that the majority of the carbon impact when you use timber comes from the transportation. So I guess the local, you spoke to it being a local material. Joe, what do you see for the UK in terms of timber being a local material and how that can make a more local supply chain and then contribute positively to all these things that Elaine brought up?
It's one of my eternal frustrations that we don't make more of our timber products in the UK. We do have forestry here, and we could use that wood for structural application in the built environment, but we tend to import most of it from either Scandinavia or Central Europe. But really we're surrounded by countries that are making engineered wood products, which are high value wood products. And for some reason the timber industry in the UK just says, our wood's not quite good enough. And I don't quite buy it. But coming back to your question before, is timber the new concrete? In some ways it is, because it's like a new and innovative material that architects are quite excited to use, and we're seeing it being used in ways that we were talking earlier on, in ways in which concrete was being used in the 60s. You've got beautifully expressive brutalist buildings on the South Bank that are just incredibly kind of expressive in their structural beauty. And timber is being used in a similar way now in some buildings, and architects and engineers are really just learning how to use it in a very creative way. So in some ways it is the kind of new concrete in that sense, whereas concrete's now looked at as the status quo or the traditional. Concrete and timber are used for different things. They're good for different things. And I think what we were chatting about before is that you need to use the right material in the right place. A timber building almost always will have concrete in it somewhere, whether it's the core or the foundations. A timber building is never really 100% timber. So that's also important to take into account, I think.
Okay, thank you so much. I'm going to start moving to the audience questions because there's some really exciting ones in here. You've given your name, so I assume you don't mind me reading it out, but Sarah Frimley from the NHS has given some very good questions. And I'll kind of merge two of the questions into one. There's one about the new hospitals programme, and that with many old hospitals being available for circular economy, is the industry ready to take this challenge in a sustainable way? And what she's added to that is, if lower carbon and circular economy costs more, ? How do you address this in public sector spending when the building need is great but funding is scarce? Whoever would like to take that one?
Looks like I got the short straw there. I'm not sure if I can answer this in a terribly specialist way, but we know how to recycle the materials in buildings, and it does require us to take a lot more trouble in terms of the way in which the project is planned and how the demolition is done, so that we don't mix the materials up in the course of the demolition. It probably will cost a little bit more, but I don't think it has to be a lot more. If we just talk about the concrete and cement side, there are alternatives today that are a similar cost to the traditional concrete and traditional cement. So I think it's something that is probably, not quite cost neutral, but it's not a million miles away.
Thank you. I actually raised this with the NHS a few years ago, and it fell on deaf ears. So I'm very keen that they look at what happens to the materials that are coming out of those buildings, because I think no one can argue that we don't need new hospitals. But it's what we do to look at what materials are in those buildings and see whether we can actually make use of them. And given the scale of what's been discussed in terms of some of these hospitals, it could actually really kickstart the local infrastructure needed to start sorting materials for reuse. I have actually kind of first-hand experience of where we've deconstructed a fairly sizable building to salvage all of the steelwork. We salvaged 1,700 tons of steel, and the demo contractor was already in contract at the time at which the developer said, "Oh, can we actually salvage all this steel rather than just cut it up and send it to recycling and turn it into new steel?" And even in that situation, the knock-on impact on programme was about 10 weeks in total additional programme on I think something like a year and a half's long programme overall. And the cost was basically due to the additional programme. Now, having said that, that was pretty much the first time this demo contractor had actually done that work. And now all of the demo contractors are contacting us saying, our challenge is how do we deconstruct as quickly as we demolish? So I think you might find that when these hospitals go out for tender, you will probably have tier one contractors coming back making suggestions as to how they can actually salvage these materials, because that's what's happening on a lot of the projects that we're dealing with.
And I guess, Elaine.
I was just going to say that I think that's a really important part of it is getting there to be a value attached to the salvage material, and that's got to be about how it can be used. And I think there's potentially a real opportunity for the NHS, so given that it is a massive client. So the interconnections between what's needed, what's used, the timing, understand. One of the real challenges with circular economy is understanding where those resources are that are available and where they're going to be needed, and at what time are they going to be released in order to be used. And you could, not take it doesn't take a big leap of understanding to see how that could work if you've got a very large portfolio, which the NHS has, of properties and assets, and to be looking at it strategically. So I think there's some, but it does require the will, and of course, and what we prioritise. So.
Truly, and I guess with the new hospitals programme, a lot of it is about standardisation, and that helps the future recyclability and reusability point. Just interesting to your point, Penny, from our experience on the time frame aspect, that there's something about salvaging materials, but the time savings that can be made from keeping a structure and reusing that can also be factored into the cost, although it's very difficult with hospitals when you're having to meet very complex space requirements and adjacency requirements. I'm going to move on. There are so many exciting questions here. We just really don't have enough time for all of them, but I'm going to go to Tom Bum's question, who says that Rix is in the news this week for addressing a mural conveying colonial resource extraction. If you drew an alternate circular mural, what would you celebrate?
Alison, it is. It pleases.
Do you know what? It might sound counterintuitive, but I'm actually going to celebrate cutting trees down, and you're probably all going to think, "What the hell?" But the reason is because then you get to grow new trees, right? And so we're thinking a lot about circularity of products here, and keeping things in circulation, products in circulation. The other kind of circular cycle we could think about is the successive growth cycles of plants, right? So that hasn't really come into this yet. What happens when you cut a forest down? What do you do with it next? I think that's a really, really critical and important question that we need to grapple with. In what way do you regrow that forest? You can have a whole plethora of different outcomes there in terms of biodiversity or carbon sequestration, and that is another part of this kind of circularity that we should be thinking about, I think. So I'll celebrate the forest and harvesting it.
Anyone else dare answer that question?
I was just going to say nature in general. I mean, that's what we need to learn from, because nature is circular.
Okay, thank you. Sorry, I'm just trying to rule. There's so many questions here. From Andy Sutton, we have, should EPDs include carbon captured in the product and an estimation of how long by default? Question mark.
I thought they did. They include sequestration, they include carbonation, which is the process with which concrete absorbs CO2. A lot of people don't know that a concrete block has sequestered a lot of carbon dioxide before it's even left the yard. But that isn't actually measured as much within LCAs. There's a lot of misunderstanding. People think, oh, it's sequestration, so I can't include it. But actually, so I believe that it is. I would like to say that what an EPD should do is include more circularity factors within its measurement. And I think that's coming, because I think that, and it's got to come through the product category rules, and that needs to be applied to be specific to the different materials. But that's going to be the best way of us being able to chat up all the different things, as well as embodied biodiversity impacts, for example. So yeah, that's the only way for us to be able to really nail this from a data point of view, is if there was more specific measurement and declaration at product levels. And of course that's going to come through digital passports for materials, and therefore added up within building logbooks, which is what you've said too.
Thank you. And that addresses a few other questions I think that were around data capture. How do you see data and material passports being used to map out existing and proposed material usage in buildings? And can that lead to greater circularity?
I'll answer the last bit first, definitely. I think data and information is absolutely critical to making circular economy happen in reality. There are various ways of recording material passport information. I think in theory we have operational manuals, we have health and safety records that should always be handed over as we get to practical completion of a building. But the problem is, where does that information go? A lot of clients that we work with don't know where it is. We get really excited as engineers if we see, a small kind of cut section of something with a coffee stain on top of it, because it gives us a clue about something in that building, which means that we don't necessarily have to do the same level of investigation works. If we find a whole set of archive information for a building, then it's like hitting the jackpot. So I think at a very basic level, we just need to record the information that we've already got. And then material passports is another step on from that. And that can be in various different formats. You can have your Revit model and your drawings, and you can have a spreadsheet that sits outside of Revit that stores that information. There are proprietary systems like Madasta that already exist, which allow you to export the information from your models and store that material, store that data. But it all fundamentally comes down to agreeing as an industry how that material is stored, where we can find it. If I'm working on a building that another engineer's worked on, how do I find that information? How do I know who's worked on that building? How do I get to it? That's the biggest problem for me. Hopefully that answers it.
Yeah, thank you. I just seen the time, completely run out of time. So I have to ask all of you, as a final rounding up, if you could make a specific request or call to action to the audience attending Innovation Zero, what would it be? What action or engagement do you believe could have a meaningful impact beyond the event? Start with Elaine. I think on the spot there, but not someone else.
Okay. Oh, there's so many different things, isn't it? I think it's quit the shortism. We've got to stop the short-term thinking. I think it's a problem with so many different things with regards to developers only just thinking about what's happening right now, and we've got to think about the big picture. We've got to think about time as a factor of this, and I think that and as part of that we need to be thinking about beyond just carbon, beyond all of these different things. I think climate change, we haven't talked about climate change resilience, making sure that things are going to last for the length of time. We need to be thinking about that. We can't be doing the same business as usual because our buildings aren't going to be in the same environment than they were in the future. So we need to be, that's, an important part of it. So yeah, it's for me, it's not just focusing on the short term. Yes, do it, but not at the expense of the big picture and the big impacts.
Thank you, Elaine. Jerry, call to action.
I would say that we all need to stop thinking so much and actually just do something. And I think that we can actually achieve together, collectively, as a group of people, collective, much more than we can individually either in our lives, in our own lives, or even in our professional lives. We all think very much about what we as an individual can change in the way that we're doing things. I think we need to kind of break out of those silos actually and think about the bigger systemic changes that we need governments to enact, changes in law, changes in regulation, changes in policy that we know are needed. And we can only really achieve if we all reach out and group together and make the same requests of government, right? So there's a huge cross-industry organisation at the moment to try and get embodied carbon regulated through a new part of the building regulations, for example, or through a new net zero carbon building standard. There's a huge collaboration going on within the industry to make a common kind of ask of government. And I would just say, join one of those initiatives and add your voice to it, and let's try and finally get some policy change to take us in the right direction.
Well said. Ian.
Yes, I was going to say something very similar, Joe. I think the question from the lady about the National Health Service is a good example of not having the right incentives. If we've got incentives that are really based only on cost and program as well, probably, then that's going to continue to get us to do the same thing. So we have to have the right incentives in place. And that really comes back to the point you were making, Joe, that these are things that governments have to do. I mean, if we all eat less meat, that's probably not really going to make a difference. Make a difference to our health maybe, but not really so much to the carbon footprint. We really have to get those incentives in place.
Thank you. That's been my favourite topic about mindset shift, but that's another topic for another time. Penny.
I think my final call to action is just don't let demolition happen without questioning it.
Great. I will say thank you so much to all of our panel, and thanks for joining us.